upper and lower sum. To approximate the area of a region, we begin by subdividing the interval AB into n subintervals. So those intervals are denoted by x sub 0 to x sub 1, x sub 1 to x sub 2, and x sub n minus 1 to x sub n. Each of which we use equal lengths because it's easier for our purposes. So the width is delta of x. Okay, this is a whole thing. It's just telling you the width is b minus a over n. So b minus a is the length of the interval. You divide it by n. How many subintervals? Now, how do you find out the x sub I, which is the right endpoint? So it is the beginning of the interval a times I times delta of x. So how many steps away from a, right? If it's the first interval, it's just 1 times delta of x, you get. So in our example earlier, we have 5 to 13, and we want to subdivide into 4 intervals. 1, 2, 3, 4, right? So what is this? Okay, if we call it x sub 1, so x sub 0 to begin with, what is x sub 1? It is 5 plus 1 times the width is 2, so this number is 7. Okay, so this is the right endpoint of the first interval. And what is the left endpoint in this case? So left endpoint is the same, a plus, okay, but instead of subscript I, is subscript I minus 1, so you just replace I by I minus 1 times delta of x. So these are the left and right endpoint, and at each subinterval, we define Ci to be the critical number such that, or not critical, but the number such that f of C sub I give you the minimum value. So in that case, we can define the lower sum. The lower sum is wherever the lowest or minimum value is, we pick that height. Okay, that height multiplied by delta of x, the width, will give you the area of that rectangle, and we add them all up. Correspondingly, if we let f of capital C sub I to be the maximum value of each subinterval, then we do the same thing. We pick the tallest bar and we multiply by the width and we add them all up, we get the upper sum. So let's see an example of what it is. Okay, we approximate the area under the graph of the function f of x equals 3x cubed. So we plot it right here from 5 to 13 for n equals 4. So what is the lower sum? So little s of 4, according to the formula, it is summation I from 1 to n f of Ci times delta of x. So this is just the formula to tell us what to do, okay? But we already know what is going on because we know the endpoints are 5, 7, 9, 11, 13. And we know it's an increasing function, so the left endpoint is the lowest or the minimum value. So we add up each rectangle, so we have f of 5 times 2 plus f of 7 times 2 plus f of 9 times 2 plus f of 11 times 2, and earlier we find out the value is 1500, 1068. How do we find the upper sum? Okay, so we also look at the formula capital S sub 4, and in this case the formula tells us to add up these 4, okay, this number should be 4. Add up these 4 rectangles, but we pick the maximum value on each subinterval. So what it is, okay, so if you take a look, Okay, this interval 5 to 7, the highest value is at 7. So it's f of 7. We're adding up instead the red rectangle here. So it's f of 7 times 2. The next one from 7 to 9, the tallest value is at 9. Okay, so we add up f of 9 times 2. And the next subinterval, 9 to 11, the tallest bar is at 11. So we add it at this rectangle, the area is f of 11, the height times the width. And similarly, from 11 to 13, at 13 we have the maximum value. So the height is f of 13 times 2. And again, using the property, right, or you factor out the common factor 2. Then you evaluate f of 7. We have it as 1029. We evaluate f of 9 is 2187. And we evaluate f of 11 is 3993. And f of 13 is 6591. Okay? And this, after you add it up and multiply by 2, the area you get is 27,600. Notice this is a lower sum. It's supposed to be smaller than the number for the upper sum, because this we're picking the minimum value and this we're picking the maximum value. And in general, if you n equals a number is given to you, and the number is small, like n equals 4, n equals 6, n equals 8, or 10. It might be easier for now to just write out the entire sum and just add up all the number like you see in this example. However, if n equals a number like 100, there's no way you can write out 100 number and add them up. That's why the summation notation come in handy, and we use the property of the summation in next example.